Okay. Hello, everyone. Welcome back to day 10 of the Advent of Code Advent calendar. As you can see, I've started putting up some Christmas decorations. It's getting nice and Christmassy over here. So yeah, here we have, let me do that. Yeah, so as you can see, haven't looked at this yet. Today I created the repository already, or the folder in my repository, but I haven't looked at it. I found this kind of fun. They seem to be spacing these out for some reason. Maybe they just want these to be longer. But this will, if they continue at this rate, they will go out of the screen at some point. Anyways, day 10, adapter array. Patched into the aircraft's data port. Oh right, yeah, we hacked the plane. You discover weather forecasts of a massive tropical storm. Before you can figure out whether it will impact your vacation plans, however, your device suddenly turns off. Its battery is dead. You'll need to plug it in. There's only one problem. The charging outlet near your seat produces the wrong number of jolts. Always prepared. I guess that's a fictional unit for Santa Claus technology. Always prepared. You make a list of all the joltage adapters in your bag. Each of your joltage adapters is rated for a specific output joltage, your puzzle input. Any given adapter can take an input of 1, 2, or 3 jolts lower than its rating and still produce its rated output joltage. So hard not to say voltage. In addition, your device has a built-in joltage adapter rated for 3 jolts higher than the highest rated adapter in your bag. Right. If your adapter list were 3, 9, and 6, your device's built-in adapter would be rated for 12 jolts. Treat the charging outlet near your seat as having an effective joltage rating of 0. That's not how this works. That wouldn't give you any power. Yeah, anyways. Treat the charging outlet near your seat as having an effective joltage rating of 0. Since you have some time to kill, you might as well test all your adapters. Wouldn't want to get to your resort and realize you can't even charge your device. If you use every adapter in your bag at once, what is the distribution of joltage differences between the charging outlet, the adapters, and your device? For example, suppose that in your bag you have adapters with the following joltage ratings. So 16, 10, 15, 5, 1, 11, 7, 19, 6, 12, and 4. With these adapters, your device's built-in joltage adapter would be rated for 19 plus 3. So yeah, because it's 3 higher than the highest one. So 22 jolts. Because adapters can only connect to a source 1 to 3 jolts lower than its rating. In order to use every adapter, you need to choose them like this. The charging outlet has an effective rating of 0, so the only adapters that could connect to it directly would need to have voltage rating of 1, 2, or 3 jolts. Of these, only one you have is an adapter rated 1 jolt, so difference of 1. From your 1 jolt rated adapter, the only choice is your 4 jolt rated adapter, difference of 3. From the 4 jolt rated adapter, the adapters rated 5, 6, or 7 are valid choices. However, in order to not skip any adapters, you have to pick the adapter rated 5 jolts. Similarly, the next choice would need to be 6, and then the one rated 7. The difference is 1 and 1. The only adapter that works with the 7 jolts adapter is rated 10 jolts. From 10, we need to go 11 or 12, but we have to use 11 because we need to also use 12. This one, and then this one, and then the 19 one. Finally, your device's built-in adapter is always 3 higher than the highest adapter, so its rating is 22 joules. In this example, when using every adapter, there are 7 differences of 1 joule and 5 differences of 3 joules. Here's a larger example. In this larger example, in a chain that uses all of the adapters, there are 22 differences of 1 joule and 10 differences of 3 joules. Sorry. Find a chain that uses all of your adapters to connect the charging outlet to your device's built-in adapter and count the voltage differences between the charging outlet, the adapters, and your device. What is the number of 1 joule differences multiplied by the number of 3 joule differences? To begin, get your puzzle input. Okay, so this one is kind of strange or weird. Like, so if we can only use adapters that are smaller than us, and we have to use all of them. So like the input or the rate we're doing them in always just has to be the sorted list of adapters, right? So we're gonna use our normal string utils, sec utils, algorithm. Probably gonna need all those. So for our adapters is gonna be the sequence of the lines in our inputs. We're once again gonna map parse int over them and not map it this time, just a normal map. Parse int, and we are going to sort the adapters. So now we can count. So let's just say 1, 2, and 3 is 0. So 4, and last, I guess, for adapter and adapters, which is now a sorted list. So we are gonna start, so last, yeah, so those 3 should be 0. Last should just be the first adapter in our list. So the smallest one. And now we can calculate the difference. Let the difference be the adapter minus last. Because this is sorted, we all know this will always be positive. I have these as 3 variables. Let's do this instead. Make this a tuple. Can I define a tuple like this? No. Wait, I can't define a tuple like this. Oh, I need to do this probably. Yeah. Can I omit one? No. Okay. Because that lets me do nums and then diff plus 1. And we can just increase that. So basically what I did here, I turned these 3 variables into a tuple. Tuples can be indexed by both names like this, but also by indexes. Oh wait, yeah, this won't work because those have to be compile time. Okay, let's just make this a list then. Or an array. That should be fine. And then we can echo out the 1s times by the 2s. No, by the 3s. So index 2. Let's try this with our example. let's try this one first. So we're gonna do this, our normal little testing here. I guess really we should I should create a small like library for this, because we are using a lot of the same stuff every single time. 4 is not in 0.2. So our difference was 2, because we never update our last. There we go. Wait, so just checking that that was done in the correct order. And echo out last in here. Yeah, so these are in order. 1, it says 1 and 1. And yeah, last is 1 because last is first. So we do 1 minus 1 is 0. 0 plus 1 is... I mean, we already have an issue there. But... that shouldn't... Yeah. Yeah, but I have to... so diff minus 1, but I have to... since I did the adapters 0 here, the first one will always be 0. I mean, I could also start counting from 1, but having an extra int that is counted as 1 isn't a big issue. So that should be fine. Let me echo out nums 1. That also means that these indexes now match the joltage differences. So 6 and 4. Oh, it didn't actually give me... Oh, okay. 7 differences of 1, 5 differences of 3. So these should have... These are 1 lower. Both of them. That's weird. I mean, we could just add 1. But... why are they 1 too low? Yeah, an adapter rated 1 jolt. Yeah, so we use the 1 that has a difference of 1. Oh wait, we were supposed to do this. We were supposed to assume that the wall had a 0. So this should actually be 0. That gives us 7 at least. And we should assume that our last one is 3 higher. So this one will always be 1 more, because our last hop is always going to be 1 more than yeah, our last hop is always going to be 3, so that's going to be 1 higher. Okay, so let's try with this, the slightly longer output, or the slightly longer example. I'm pretty sure this works now, but let's just try it for fun. Delete this. Oops, that was the wrong button. So that is 22 and 10. Yeah, so 22 of 1 and 10 of 3. So that works. Now we can remove that, delete this part, and delete these two. And that should give us the response to question 1. Woohoo! Part 2. To completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. Every arrangement needs to connect the charging outlet to your device. The previous rules about when adapters can successfully connect still apply. So the 1 to 3 voltage range. The first example above, the one that starts with 16, 10, 15, supports the following arrangements. So now we don't have to use all of them. So this is like all of the ways that we can connect 0 to 22, but we now don't have to use all of them anymore. So the charging outlets and your device's built-in adapter are shown in parentheses, giving the adapters from the first example. The total number of arrangements that connect the charging outlet to your device is 8. The second example above, the one that starts with 28, 33, 18, has many arrangements. Here are a few. Yeah. In total, this set of adapters can connect the charging outlet to your device in 19,208 distinct arrangements. You glance back down at your bag and try to remember why you brought so many adapters. There must be more than 1 trillion valid ways to arrange them. Surely there must be an efficient way to count the arrangements. What's the total number of distinct ways you can arrange the adapters to connect the charging outlet to your device? So let's just first start off with copying part 1 over to part 2 and open that up. So I can see why people have been struggling a bit with this, but I think I have a simple solution. So currently we're using all of them. We're sorting them, and we're just using all of the adapters. Basically, the only time when we can not use an adapter is when, so for example here, we can skip using 5 because we can go directly from 4 to 6. We can never skip using 4. As you can see, all of the valid options here have 4 in it because 1 and 5 are too far away. So we can skip 5 because we can go directly from 4 to 6 because it's only 2 away. And we can also skip 6 because we can go directly from 4 to 7 because it's 3 away. But we can't skip 7 because we can't go from 4 to 10 because that's 6 away. Which means that we have to check, let's see. Yeah, so since we can skip 5, you can see here we have half of our list of arrangements has 5 in it, and half of it doesn't. And also half of the list has 6, so these and these have 6, but these and these don't. So half of the ones have 6, half of the ones don't, right? That means that, 6, 6. So every time we skip a number, we get twice the amount of ways of connecting them. So if we start with 1 and there was 1 adapter we could skip, so if we could only skip 5, then we could have this, and we could have this without the 5. So we could have 2 possibilities. So basically all we have to do is to set say that we have one possibility, then loop through the list and see every time we find adapters that we can skip, we double the count of available solutions. So for this, the amount of arrangements is 8. That means we have doubled it. What is it, 4 times? So we double it from 1 to 2 when we find the 5. Then we find the 6. We double it from 2 to 4. 7 always has to be there, but we can skip 11. Yeah, we can skip 11. We can't skip 12. So we can skip 11. That doubles it from 4 to 8. And we loop through the rest and see we can't skip anymore. So that's our number 8. Yeah. So we need to loop through, figure out when we can skip. Ways is 1. We can always have one way. We know that because we went through it before and we found our one way of doing it. So we need to loop through our adapters, and then we need to look ahead. You need to look ahead at our following adapters, and if they are in the -2 so if the next ones are high enough. So let's grab the index here as well. Let's just not do any of this. So while so we need another one here, while and this must be +1, while adapter at position J minus this adapter is smaller than 3. So 1, 2, or smaller than 4. So 1, 2, or 3, or 0. That should never happen. So while the adapter n steps ahead of us, so in here we're obviously going to increase J. So while adapter n steps ahead of us is within that range, we basically just double. Do we have that operator in them? Yes, we do, but this is complaining about something. That should be adapters. So yeah, while it's small enough, we double the amount of ways, and we increase J. So that should give us the ways. Let's again just test this with our test inputs. That's the first example. This should give me 8. I think this should work. Split lines, map, %. There might be something I've missed that. No, we don't want to do that. There might be something I've missed that makes this unfeasible. Of course we need to while adapters the high is the length is smaller than J, and there. Adapters. That gave me 1. So this never ran, unless this is doing something other than what I'm expecting it to do. No. So we go through the adapters. J should always be the next one. So let's echo out the adapter and the adapters thing here. 1 and 4, 4 and 5. So 4 and 5 should be small enough. Oh wait, we have this the wrong way around, don't we? No. So 5 minus 4 is smaller than 4. What? Echo adapters at length smaller than J. And echo adapters J minus adapter smaller than 4. I just wanted to see which check fails on that. So 1 and 4, that's fine. 4 and 5. This one is false. What the hell? What does it think adapters at length is? 11. Oh. No, wait. What? What is J here? Oh god, this is getting unreadable. J. So for this case, 4 and 5, J is 2. But somehow... oh. Damn it. I of course need the length of adapters to be larger than our position. And that's way too big. Okay. Ah. Right, we already double it. Can be removed. Let's create here a set of units. If adapters J not in can be removed. Can be removed dot include this adapter. Oh. I'm assuming UN16 is large enough here, but let's check that real quick. Yeah, plenty big. Could probably get away with a UN8. 1024, it's still too many times. Let's echo out our I's and our J's here. Not sure if I'm just doing something really dumb or if I've missed something in the logic of this. So I is 0, J is 1. And that shouldn't be a case. Let's see here. Yeah, so I and J, 0 is adapter 1, 1 is adapter 4. And we can't skip 4. Because it has a difference of 3. Should this be... Oh, wait. Yeah, my logic is wrong here. I need to check them. I need to check upwards until I find one that... Yeah, okay. J, don't do this. So, go upwards until you find one, or until you find one that isn't bigger. So start on the next +2, right? So from position 0, we start with 0. Let me actually just make this a bit easier on ourselves. We are going to add a 0 to there. I mean, I'm not sure why I ran that, but okay, so now we have a 0. So from 0 to 1. So yeah, okay, so from 0, I go to adapters N, which is adapter number 4. And I know I can't remove... we can also do... so after sorting, just grab the highest adapter and add 3 to it. Right. So 0. So we take the 0th, we take the 4, and now we can see, this difference is too high, so we can't skip the 1 in between here. So if j after this looping is larger than I plus 2, so if we increased it once, so if we looked at 4 and said, yes, the difference between our number and 4 is smaller than 3, that means we have found, that means that the adapter between 1 and 4 can be skipped, right? We can actually do while and decrease it, decrease j, and ways should times by 2. That's 8. Great. We didn't need this because that was a tiny mistake on my part. Yeah. I think my explanations and stuff are super incomplete at the moment. And I'm, again, not remembering to read chat. Right. Yeah, the wording on this problem tripped you up. Yeah, it was a bit weird. Like the wording was a bit weird. But for some reason my brain can't completely English today, so that might be why. But this one seems too high. That should be 19208. 19208. (19208) isn't a multiple of 2. Yeah. So my logic is flawed here. It always needs to connect at the highest voltage, right? Not that that should matter. How can it get 19208? So every adapter can be on or off, or like used or not used, right? In theory. And for every adapter that does that, we double our possibilities. Unless there are some you can drop conditionally. Yeah. So if we drop one, we might not be able to drop another one. So our solutions might be mutually exclusive. Oh, that's a bummer. This is basically what I'm saying. Like in this, we didn't have any of that. But if so for example, I can't drop. I mean, in this one we didn't have that. But if the 6 wasn't here, so these two would obviously go away. But I couldn't skip. No, that was a bad example. 10, 11, 12. Like if I skip 11, I can't also skip 10. So if you had 9 in here. Yeah. Does this mean we need to actually compute the list of possibilities? And like sanity check them? Now we should be able to. I'm too tired for this. Basically, it's not. It can't be always that we have to not divide by 2, because this isn't a multiple of 2. Or yeah, power of 2, I guess. No, multiple of 2. Like, there's no way we can time by 2 and get this number. So 1, oops, start my calculator here. Times by 2, times by 2, times by 2. Go like this. There's no, at no point will we reach this number, because it's not a multiple of 2's. Yeah, you see we get to there and then go past. This was annoying. I mean, I could remove insanity check. We have the adapters. We have the adapters that we want to remove, or that we think we can remove. Yeah, so some of them aren't doubling our set of possible solutions in the case where we can't in the case where we can't drop all the adapters between X and Y. So in this case, let's see. So here we think we can drop dropping and then adapters J. So these are the adapters that we think we can drop, right? And there should be a series here, I guess. No. So what do we have? List out my adapters, please. Oh wait, I'm dropping my last one. Probably shouldn't do that. Like my last one is well, oh wait, what? First off, this should be like this, shouldn't it? No, never mind. So J must be smaller than adapters dot high. Oops. And so yeah, don't drop don't drop our last one. So how much smaller? Just out of curiosity, how many? So this is 16384. Oops. Again, enter my calculator. 16384. For those of you who don't know, that's Stacklang. It's a calculator I made. But now that seems divisible by 2. No. But now it says we have more, so we have missed some opportunities. So it has found some other distinct arrangements that we didn't find. So I say we can drop 3. He has no one where he drops 3. But I don't mention that we can drop 1 and 2, which he happily drops. Oh wait, do I? No. Oh wait. It should actually be this, I guess. Yeah. So I say we can drop 1 and 2 because if we can go directly from 0 to 3, we can't drop 4, but right, we can drop 3, but not if we drop 2. Right? But why does this say we can't drop 3? Because when I is 2, it should see the 4 and say that we can drop the 3. So my logic is both flawed and not working. I mean, it's both flawed and my implementation has issues. 1, 2, 3. This is going to be painful. This is the kind of stuff I don't like doing. So first I want to try to fix this. Wait, should we try and fix it? Because we have conditionals. So if this... Basically, if the adapter we have can be dropped, we can't time by 2. We can only... Yeah, so they are conditional on each other. So if I drop 1, then I can't drop another one. Let me grab this list pre-sorted here. Okay, and just insert it here. And we're gonna do this. We're gonna remove. I just wanna like find where oops, that's not the right one. What's the new line character in Vim again? Yeah, as you can see, I've been searching for this before. It's not \n though, it's something else. Remember, replacement does not mean new line. \r. There we go. Oops, and this needs to go like that. So this is basically the exact same thing. Just pre-sorted the list. Because I want to find the case where, like, if I delete up to here, do we still get a weird result? Wait, shit, I have no way of telling without manually making all of these things. Crap. Oh, that was a waste of time. Okay, so in this example, we can skip 1, right? You can skip 1, you can skip 2. So we can go from 0 to 3. Now from 1, we can skip 2, we can skip 3, and go directly to 4. For 2, we can skip 3, and go directly to 4. For 3, can't skip anything. Our problem is that we can't skip 1, 2, and 3 at the same time and go directly to 4 from 0. But all of these can be skipped by their sort of at some point each of these can be skipped, but they can't be skipped all at the same time. So the combination is not just times by 2 every time, because they're not mutually exclusive. Why didn't this show up as an error in the first one? Because here we also have sequences, don't we? I guess we don't have 3 long sequences. Yeah, we do. We have 4, 5, 6. So is the 4 long sequence? 1, 2, 3, 4. And what is this? What is the number? So the problem here is that we can't try every combination of missing adapters. Because, let's see, just for fun here, just all of our adapters, don't echo them out because there are quite a lot of them. Let's reintroduce our can be removed thing. Just a set of UN16. And can be removed, include adapters J -2. Not sure how that precedence works. And echo out can be removed dot cardinality, so the size of the set. Yep, convert this to a UN16. Word. It should be -2 there. Not just -2 on the value. Like so. So we have 44 values we can drop. That's not too many. Are we sure we can't just do all of them? Are we sure that this isn't just the right value? And that this has some edge case that we don't have? I'm not going to try to submit this. It might be the right number, but I would feel dirty if it worked because it's not a general solution. So we have 44 numbers that can be removed, that like logically can be removed. If we generate all of those possibilities with like on or off, oops, it's only like 2,000 possibilities. No, wait, what? That's not right. Yeah, no. This will be in the yeah, this kind of number size. Right. 1759. Because we're looking for the legal number of options Yeah, this should be. Oops. No. Clear my calculator. It's this number, which is actually the same as this one. Which makes sense because that's what that number is. But we need to figure out when some of these can't be removed and subtract some of the routes or some of the sequences based on if it can be removed at the same time as someone else. So it's so some of these trillions of possibilities are not possible to remove. And the reason they're not possible to remove is because they're a sequence like this. Right? So they are a sequence of numbers, so they can't be removed. Oh. Someone had to drop my stream. I mean, I think this number might be right for this solution. Just based on our input set. Ah, no, okay, it's not. It's too high. So we do have this condition. So we have 3 in a row there. We have 12, 13, 18, 19, 20. We have 3 in a row here. 28, 29, 30. We have 3 in a row there. 3 in a row there. 2 in a row. 3 in a row there. 3 in a row there. 3 in a row there. And 3 in a row there. So there's something about these 3 in a rows, I think. Because we have that in this one. But we have 4 in a rows here. Did we calculate this wrong in our example? Am I just too tired to see the obvious solution? Oops. That's not what I wanted to do. So this is with the one that should be slightly higher than what we get. Wait, slightly higher? Wait, it can't be higher? Because we need to eliminate stuff. I actually have to go in not too long as well. Because I have stuff to do today. Yeah, I think I actually have to go now. Well, this was annoying. First one I failed so far to do on stream. Okay. But yeah, so this didn't work. I have to go because I have stuff to do, like eating dinner and getting some friends over afterwards, which is fine here. Just by the way, I'm not breaking any rules. Yeah. I have to think about this. There is some strangeness going on. Because we can't test every possibility. I mean, maybe if I just write the code to test every possibility, I could start it now and then I could go do whatever and submit my answer by night. But that's a lot of combinations. So basically some of the combinations are mutually exclusive, so we can't remove them. I think I just realized why R1 was the one for the first example was low and not high. And it's because I do this check, which should be like that. Well, it will never be that. Yeah, anyways. Yeah, so there is some stuff left to do. I don't have time to do it now. Yeah, bit of a underwhelming stream today. Hopefully I'll figure it out. Maybe I'm able to stream more in the evening today, but I don't think so. Hopefully I'm able to solve this before I need to go to bed. In any case, I hope to be streaming again tomorrow. Hopefully we'll be able to do that one by then. And hopefully I'll be able to do this one before I go to bed. In any case, have fun. Have a nice 10th of December, 10th day of Advent.